Now we had a definition of the number e, and we're now going to be able to obtain this number e as a limit. Let's start with the natural log function, and if we took the derivative of this natural log, we would have 1 over x. Now we're going to consider the derivative of this function at 1, and so we're going to write this using definition of derivative. The limit, we're going to use x approaching 0 of the natural log of 1 plus x minus the natural log of 1 all over x. The first thing we're going to do here is say, well, the natural log of 1 is 0, and then just express this over x as a 1 over x here, and using log properties we can move this, third property of logs, we can move this as an exponent. And now because this was the derivative of the natural log function evaluated at 1, that would be 1 over x evaluated at 1, so this would need to equal 1. Now what we're going to do then, because this limit equals 1, we're going to express e as e to the 1, and we're going to substitute in for the 1 this limit. So there we have it. Looking at this exponent, we have the limit of this function inside of a function, and so we have that property that we can move the limit and apply it to the inside function and then apply the outside function. But e and ln are inverse functions and they undo each other, and so we are left with the limit as x approaches 0 of the quantity 1 plus x raised to the 1 over x power. Now what we started with here was e, and what we ended up with is this limit. So we can express the number e as this limit. Looking at this graphically then, as x approaches 0, we know that 0 is excluded from the domain of this function, but as we approach 0, we approach this number e, and we knew e was about 2.718 and so forth, and you can see that that is the place where we have this hole. We can go ahead and look at a table of values and let x get nearer and nearer to 0, and as we compute values for x very close to 0, we will be computing values very close to this number e. So here is our table of values, and we see as x gets closer and closer and closer to 0, and we compute this function here, that we get a number that gets closer and closer and closer to e, and in fact this last one here is correct to 7 decimal places for our number e. Now let's look at this e, and let's do a change of variables. We're going to let x equal 1 over n. So if we had this and we let x approach 0, for this fraction to approach 0, n would need to be approaching infinity. And we also could express this as n equal 1 over x, and so we could replace this 1 over x with n, and we could replace this x with 1 over n, and we'd have another way to express the number e, the limit as n approaches infinity of quantity 1 plus 1 over n, and then raised to the nth power.